Hi everyone. Today let's look at the LeetCode problem 121. Best time to buy and sell stock. So you are given an array of prices, okay, where prices I is the price of a given stock on the ith day. So you can think this way, right? So 0th day or the first day this was the price, second day, third day, like that you are given. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock, and return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So just to give a picture, you are given an opportunity to buy the stock once and sell it once, and you have to make maximum profit. That's the request. So now let's try to build an intuition for this problem. How to solve this problem? We'll come to this part, but when you start such problems, try to visualize and see how this works. So if you see here, given this question, it's very clear that if I bought my stock on the first ith day, which is first day, okay, here, and sold it on the fourth day, that would be my maximum profit. I would make a profit of 5. Okay, now let's see how to solve this problem. Take these two data points. One is the maximum profit that I can get until that given index. So including that index, what is the maximum profit I can have? And I'll just keep track of it and come to the end. And similarly, I will also keep track of the minimum price of the minimum price at which the stock can be bought, including that index. So I believe this is clear. So this will keep track of the maximum profit that I have attained till this point or this point at each index. Okay. So that at the end, I will get the maximum profit. I'll keep track of the maximum profit. And here I will just keep track of the minimum price within this given indexes. So now let's start here. Okay. So our base condition, of course, here you would not make any profit because this is the first day. So you will not be able to buy it before this. And your minimum price until this index will be 7. Because this is your first one, right? So this is your base condition. Now let's take this index. At this point, if you see, we will not even make any profit. So because this is 7 and this is 1. So you can tell that you don't make any profit here, even if you buy it before. So yeah. And at this point, what is the minimum price including this? So that will be 1. So that means this will have a change here. So we'll take this one and the minimum of this value and put it here. Okay. Now, if you see here, this will become, now here we could get a profit because this will become 5 minus 1, which is 4. So you will get a profit here. Okay. And this value and 4 is greater than 0. So you can put it here. Okay. And then still the minimum price will be 1,5, min of 1,5. So it will take 1 only. Next we come here. Now if you see, if I subtract 3 and 1 from 3, I'll get 2. Then I can just compare the maximum value of 4 and 2. So still the my maximum profit is 4. That is the case where I sold it when it was 5. My minimum price until given index is still 1. Same. Now let's go to 6. Okay. So assuming I bought this at 1 and I sold it at 6, my profit will be 5. This is greater than the maximum profit I had till now. So this value will become 5. And this, of course, will still remain 1. So here also, even if I sold this will be 3,5. 5 will be still the maximum profit. So I'll just keep it there. And yeah. So if you see here, you could ideally, if you see here, this always only depends on the last value of, for our calculations, we only depend on the last value. So we could ideally just maintain one variable one variable for maximum profit until given index, and minimum price to track the minimum price, one variable each, thus taking only constant space. So it will be a order of n because you have to iterate through the entire array. Okay, and the space complexity will be order of 1. I will start with 2 variables to make it more make it much easier to understand. So let's put this way. This will keep track of our max profit. Okay, and we can just put it as prices dot size, comma 0. Okay, and we will also keep track of another variable to keep track of another vector to keep track of the min price, min price dot size, comma 0. Now I'll also set my min price of 0 to be prices of 0. This max profit is already 0. I'll just keep it as 0. Now let's iterate through the array. Okay, a less than prices dot size plus plus. Okay, now what we'll do is, first thing is, let's see int current profit, right? Okay, what is the current profit that we could get? That will be actually prices of I minus min price of I minus 1, the previous min price. But this makes sense only if this prices of I is greater than 0. Sorry, prices of I is greater than min price. So we could put a condition here telling that, hey, I'll make it more readable. So we'll just tell if it is greater than or equal to, I'll just put it that way also. So then we will consider this, okay, or else we'll just make it as 0 because you will not get any profit. Now what we'll do is we'll take max profit of I equal to max of current profit, comma max profit of I minus 1. Okay, all right, so this is clear. Now we have to see at this point what will be the min price. Okay, so now what we'll do is we'll take min of min price, comma prices of I. Okay, and so now it will iterate through the array. Okay, this will be I, comma I minus 1. All right, now if I return max profit dot back, that should give us the output. If you see, this will be an order of n. This will be an order of time complexity will be order of n. Okay, and space complexity will be order of 1. So if you see here, there is one thing you can notice. There is only dependency on the previous value for max profit, previous value of max profit and min price. That's all we need. So instead of doing this, I could actually just convert this to a single variable. So what I'm trying to do is, actually, we could just have this as a int max profit is equal to 0 to start with, and we could just have int min price equal to the price of 0. Then what we'll do is we'll go through this one, we'll get the current price, that is nothing but, so the min price will denote your previous min price, okay, and your same here, okay, and your max profit is basically max of current profit, and the current max profit value is basically the previous max profit that we could have got before this index. Okay, and same way you can also keep track of your min price, comparing it with the previous min price value and the current price. Now this should give us the same output. I can just take these out before submitting. So here, when I mentioned earlier, this would have been space complexity of n, the previous solution. So now it's order of 1. So thus we can tell, your overall space complexity basis. So that's it for today. Thank you.